Question 8. Define the term enthalpy change, heat energy change at constant pressure. One marker, this one is a more shorter definition. Heat energy change compared to like standard enthalpy of formation, standard enthalpy of combustion, etc. etc. So heat energy change at constant pressure. Then we've got question 8.2, 4 marks, and it doesn't look easy because since question 8 is the last question of this paper, and I don't think it's going to be easy. No, 4 marks. It says calculate a value, use data to calculate a value for carbon-carbon bond enthalpy in propane. We know delta H is this. Now we're working with bond enthalpies, so it's going to be energy required to break bonds. No, that's not it. Energy required to break bonds minus energy released when new bonds are formed. So delta H, bonds broken, minus bonds formed. You can just say shorthand bonds formed, energy required bonds formed. So delta H is minus 2046. And that's equal to the energy required to break the bond, C3H8. Now what I like to do is draw out what that is, C3H8. Because then it just gives me a better idea of how many bonds we're talking about, what we're working with. So we've got 1, 2, 3, 4, 5, 6, 7, 8 CH bonds. So it's going to be 8 times by CH 412 plus you've got carbon-carbon bond, carbon-carbon bond, but that's what we're trying to find. So plus 2x plus 2x, and then we've also got 502. So bond enthalpy for older bond is 496, or 496 times by 5. Sorry guys if I'm saying a lot. Very not tired, it's just very worn out. I don't know what the word is, but I'm still gonna get this video done and the next paper as well by the end of today, that's for sure. The minus 3 CO2. The thing about CO2, we've got C double-bond-O. So what's it going to be? Well, it's going to be 1, 2 in each one. We've got 3 of them, so it's going to be 6 CO2. So it's going to be 6 CO, which is going to be 6 times by 743 plus 4 H2O. Again with H2O. HH. It's going to be 8 OH, so plus 8 times by 463. You can see how it's getting complicated. And we also know to convert from H2O liquid to H2O gas is plus 41. So what we need to also add is that plus 41. So it's going to be, so we've got how many H2O molecules working with 4, so it's going to be again plus 4 times by 41 because we want to convert it into gas. Now it's a matter of not making any silly mistakes when you put in the calculator. 8 times by 412 plus 496 times by 5, 5776. And we're subtracting that by 6 times by 743 plus 8 times by 463 plus 4 times by 41, 83. So we should get this 5776. We've also got 6 CO2, 6 CO, 6 times by 703, 743 plus 8 times by 463 plus 4 times by 41. So we've got this 6 times by 743. You can see, guys, how this gets complicated. But I'm just trying to verify everything that we've done so far. But we should get. Okay, let's do this. We subtract minus 2x, we get minus 2x equals minus 2046, and then we add 2046. So it's going to be 5776 minus 8326, add 2046 minus 504, and then what we're trying to find is just one x, c double bond c, c carb single bond c. So x is going to be 252 because the negatives will cancel out. So 252. That is the correct answer. 252 kilojoules per multiplier minus 1. So you can see how it's definitely not easy, but it is doable. Knowing the equation, delta H bond broken minus bonds formed, and you quite a break bond, hence you release when new bonds are formed. Also, this point, well, we want it in the gaseous state, so we've got 4 moles of that, so we need to times this by 4, 4 times 4, 41. And then just drawing the molecules out so we can see how many bonds are working with. And then 8.3, explain why the value given for the O bond O and bond delta P 496 is not a mean value, whereas the rest of them it's a mean value. Well, because oxygen is the only substance that has O double bond O, of course, in this case from the table. Oxygen is the only substance that has the O double bond O bond, therefore it's not a mean value. And that is the end of question 8.